All right, this is problem 4.59. It's an inclined plane, angle is theta, and it's a crate on it that has a mass m. In the picture they show the y-axis there and the x-axis there. It says theta is 22.5 degrees and mu k is equal to 0.19. I'm assuming it's going to slide because they're giving us mu k and not mu s. Question is, determine the acceleration of the crate as it slides down the plane. So if we change colors here and do a free body diagram, we have FG, which we break into FG perpendicular and FG parallel. The fact that there's friction here tells me that there's some FFK in this direction, and there's also a normal force there. We know some of the forces in the perpendicular direction means that Fn is equal to Fg perpendicular, which, if you remember, there's a C in it, so it's Fg cosine theta, or you can be better at math and figure that out. Fg parallel is, I was going to say mg, but Fg sine theta, which we know is mg sine theta. And the friction force, if we want to calculate it, is mu Fn, and this is friction force kinetic, so we use mu k, so that's 0.19 times Fn, but Fn, we just said, was Fg cosine theta. So let's put that, cos theta, and actually we know Fg is mg, so it's 0.19 mg cos theta. So we have identified the value of all these forces. Now we have to do F net equals ma to find A. We go to F net. This side of the equation is a little bit harder. We have to look at the sum of the forces. It looks like we have this and this battling it out. So the answer would be Fg parallel is winning minus FFK equals ma. So if we plug in all these things, we get mg sine theta minus 0.19 mg cos theta equals ma. We can get rid of the m's, and it looks like a is equal to 9.8 times the sine of 22.5 minus 0.19 times 9.8, and I'm running out of room, cosine 22.5. You guys can probably do the math from here. I'll do it real quick on a calculator. 9.8 sine 22.5 minus 0.19 times 9.8 cos 22.5. I got 2.03 for my numbers. Your numbers might be different than mine, so you're going to have to double check. I'm going to check it in mastering just to see if I get the green light. I got it, but it says it was either rounded differently or used different numbers as sig figs. It looks like they just wanted 2.0 meters per second squared because they only gave us 2 sig figs, although theta had 3. All right, so that was part A. Part B of this, really quickly, if the crate starts from rest 8.4 meters up, so 8.4 meters, this is where the crate started. What will the crate speed when it reaches the bottom? So we're combining now F net equals ma in kinematics. So once we find A, we can apply it to our big three. If you want the v at the bottom and you're given what delta x is, and delta x can be this direction, it's a one-dimensional problem, I would do vf squared equals v initial squared plus 2a delta x. And if you do that, it starts from rest, so this is 0, 2 times 2 times 8.4 meters, don't forget to square root it, v final is I got 5.8 or so meters per second. And I'll check that real quick just to make sure I did it right. 5.8 meters per second. Submit. Oh, it's a good night. I got another green. All right, I'm done with this one.